Okay, once again, welcome back to an interesting class here for you of your class 12 physics. I am discussing of chapter magnetic effect of electric current, an important derivation of Biot Savart law for you. Yes, and here I am going to discuss the derivation of the Biot Savart law. Here the statement is that state and explain Biot Savart law for magnetic field by current element. Define the SI unit of magnetic field from this law. Yes. The state and explain the Biot-Savart law for the magnetic field by current element. Define the SI unit of magnetic field from this law. It means the Biot-Savart law is mainly focused to find the magnitude of the magnetic field due to a current element. So what is current element? The current element is the part of the conductor, a small part of the conductor, where you have to find out the magnetic field at a point, at a position, okay, and from the current element. Okay, so the Biot-Savart law is mainly focused to find the magnitude of the magnetic field due to a small part of the conductor. So current element is nothing, the small part of the conductor, the segment of the conductor, okay, due to which we have to find out the magnetic field at any point around it. So as per the Oersted experiment, and which already know, a current carrying conductor produces a magnetic field around it. So when there is a electric current flowing through a conductor, so there is a magnetic field around a current carrying conductor. This is the concept was given by Oersted experiment. Yes, all of you know. And here it is saying we are in the Biot-Savart law, you have to find out the magnetic field due to current element. And this magnetic field, the Biot-Savart statement tells are mainly focused to find the magnetic field due to a small segment of the conductor. And the small segment of the conductor is known as current element. So the magnitude of the magnetic field is due to the contribution of the different segment of the conductor is called current element. Okay, understand? So magnetic field due to a small segment which is known as current element. Okay, so a current element is a small part of the conductor. Current element is a small part of the conductor. Yes, here the current element is a small part of the conductor denoted by letter dl, in which the current flows as in the same direction as that of electric current. So in 1820, two French physicists, Biot and Felix Savart, deduced an expression for the magnetic field of electric current due to current element, which is popularly known as Biot-Savart law. So here the Biot-Savart law is mainly focused to find the magnetic field due to a small part of the conductor, and this small part of the conductor is known as what? Current element. Let's see. Yes. So let us consider a current element dl of conductor xy carrying the electric current I. Here I is the small part of the conductor. Yes. Understand? So let P be any point where the magnetic field dV to be calculated due to the current element dl. Let us consider small current element dl whose length is dl. dl is the current element, and this is the part of the conductor, segment of the conductor, small part of the conductor, and whose length is dl. And here and you have to find out the magnetic field at the point P due to the current element dl. Okay, let and r be the position vector of the point P from the current element dl. Understand? And here you see theta is the angle between the position vector r and the current element dl. Yes, this is the angle between the position vector r and the current element dl at the point P. So here we have to find out the magnetic field at the position P, okay, and due to the position vector r from the current element dl, and here theta is the angle between the position vector r and the current element dl, right? So let theta is the angle between the position vector r and the current element dl, right? So according to Biot-Savart law, the main statement of the Biot-Savart law is that the magnitude of the point 1 I am discussing, first point I am discussing, and the magnitude of the magnetic field is directly proportional to the electric current flows through the conductor. Yes, it means the magnitude of the magnetic field is directly proportional to the length amount of current flowing through a conductor. Is it clear? So if the amount of current flows through the conductor will increase, then the strength of the magnetic field will also increase. Yes, and vice versa, right? And second point is that the magnetic field is directly proportional to the length of the current element dl. It means if the length of the current element will increase, the magnitude of the magnetic field also will increase. Yes, understand? So here the magnetic field is directly proportional to the length of the current element, right? Uh, third point is that, third important point is that of the Biot-Savart law, the magnetic field is directly proportional to the sine theta. Understand? And fourth point, the magnetic field is inversely proportional to the square of the distance r. Square of the distance r, okay, of the point P from the current element. Okay, understand? So here you see the magnetic field is inversely proportional to the square of the distance of the position vector of the point P from the current element. Yes, of the current element. Understand? It means if the distance of the point from the current element increase, then naturally the magnetic field will decrease, right? Yes. So combining all these four conditions and four factors we shall get, and here the magnetic field is directly proportional to I into dl into sine theta upon r square, and thus we get the magnetic field is equal to k into I into dl into sine theta by r square, where k is the constant of proportionality and dv is equal to k into I into dl into sine theta by r square. This is the required derivation of the magnetic field due to the current carrying and due to the small current element, small segment of the conductor. What is k? And here k is the constant of proportionality, which is depends upon the medium between the point of observation and the current element and system of unit choosings. So for the free space, the SI unit of k is mu 0 upon 4 pi, which is equal to 10 to the minus 7 Tesla in meter per ampere. Understand? And k is equal to mu 0 upon 4 pi is equal to 10 to the power minus 7 Tesla into meter per ampere, where mu 0 is equal to 4 pi into 10 to the power minus 7, the value of mu 0, which is known as permeability of the free space, okay, and for the Biot-Savart law. And here the magnetic field dV is equal to mu 0 upon 4 pi into I into dl into sine theta upon r square is the desired expression for the Biot-Savart law, okay. And since the magnetic field is a vector quantity, okay, and the magnetic field is always perpendicular to the plane containing the current element and the displacement vector or the position vector r. So we can write the Biot-Savart law in the vector form. So dV is equal to mu 0 I into 4 pi into, okay, so cross product of dl and the position vector r upon r cube, right? Understand? So this is the vector form. This is the vector form of the Biot-Savart law. Yes. Understand? Okay. Okay. Let's see now. What is you see? What is the direction of the dV? Direction of dV. Direction of the magnetic field due to the current element. What is the direction of the magnetic field due to the current element? Yes. And here you see, and this is the, and the magnetic field is what? Is a vector quantity. Vector quantity. Suppose this is the length of the current element dl, and this is the position vector, and here this is the direction of the magnetic field. This is the direction of the magnetic field. Understand? Okay, so the direction of the magnetic field is the direction of the vector containing the vector dl and displacement vector r. Yes or no? Okay, so direction of the magnetic field is perpendicular to the plane containing the current element dl, vector containing the current element dl and the position vector r. Okay, understand? And already you know about the right hand screw rule, and if you place a right hand screw at a point P, okay, and which is perpendicular to the plane containing the current element dl and the position vector r, and you will see what you will see here, And the displace, you say magnetic field is always perpendicular to the plane containing the current element dl and the position vector r. Okay, this is in accordance with the right hand screw rule. Okay, and this is the definition. The vector from of the what cross product of the vectors is that, and so, and the direction of the magnetic field is always perpendicular to the plane containing the current element and the position vector r. Is it clear? Understand? Okay. So here is saying, let us consider special case over that. Let us say, suppose case 1 you see. First case you see. When theta is equal to, you see, when theta is equal to 0 degree. When theta is equal to 0 degree, you will see, then what is the magnetic field? The magnetic field will be what? You see now, if theta will be 0 degree, then sin theta will be what? 0. Yes. Sin theta will be 0. And the magnetic, understand, the magnetic field, value of magnetic field will be also 0. Will be also 0. This is one case. And other case is that, if another case we can discuss, suppose, and theta is equal to how much? Theta is equal to 90 degree. Theta is equal to 90 degree. Understand? That means the position vector of the point P is perpendicular to the plane containing the perpendicular to the what? Current element. Then in this case, sin theta is equal to how much? 1. Sin theta is equal to 1. And here dV is equal to how much? The mu 0 by 4 pi, mu 0 by 4 pi, what? I dl by what? R square. I dl by square. And the value of the magnetic field will be maximum. And the value of the magnetic field will be what? Maximum value. We will get maximum value of the magnetic field when the position vector is perpendicular to the current element dl. Yes. Understand? Okay. And here is seeing another important concept. The SI unit of magnetic field. What is the SI unit of magnetic field? SI unit of magnetic field. Yes. Understand? The SI unit of magnetic field is known as Tesla. What is the SI unit of magnetic field? The SI unit of magnetic field is known as Tesla. Yes. Understand? And as per the derivation we know, here dB, the magnetic field is equal to mu 0, okay, divided by 4 pi into I into dl into sin theta divided by r square. Yes or no? This is the derivation of I. Okay. So suppose I am taking, and I is equal to suppose 1 ampere. Understand? And the length of the current element suppose 1 meter, and theta is equal to 90 degree. Yes. And r is equal to 1 meter. R is equal to 1 meter. Understand or not? Okay. Then, and all of you know mu 0 is equal to how much? Mu 0 is equal to 4 pi into 10 to the power minus 7. 10 to the power minus 7. Okay. This is the permeability of the free space for the Savart law. Right. So, if you putting this value here, we shall get, and dB will be what? It will be 10 to the power minus 7. It will be 10 to the power minus 7 Tesla. Understand or not? By putting these values, okay, and we shall get dB is equal to 10 to the minus 10 Tesla, right? Or that implies, and if you then 1 Tesla, we shall get what? 10 to the power 7 into dB. Okay, so can you define 1 Tesla? The SI unit of magnetic field is 1 Tesla. What is the meaning of that? So 1 Tesla, yes, the 1 Tesla is 10 to the power 7 times to the magnetic field produced by conducting wire of length 1 meter of length 1 meter, understand, and carrying electric current of 1 ampere at distance of 1 meter from it and is perpendicular to it. Yes, understand. So you can define 1 Tesla. So 1 Tesla can be defined. Okay, so 1 Tesla is, what is 1 Tesla? Is 10 to the power 7 times 7 times the magnetic field produced by conducting wire of length what? Of length 1 meter. Of length 1 meter and carrying a current of 1 ampere. Current of 1 ampere. 1 ampere is at a distance of 1 meter. A distance of 1 meter from it, from the current element of length, from the current element and perpendicular to it, and always perpendicular to it. Yes, it means the angle between the displacement vector and the due to the position of the point, due to the position vector and the current element is always 90 degree. Okay, understand? So it is clear regarding the SI unit of the, what is the SI unit of the magnetic field is Tesla, and it is 1 Tesla is 10 to the power 7 times the magnetic field produced by the conducting wire of length 1 meter, yes, and carrying a current of 1 ampere, a distance of 1 meter, and from the current element and always perpendicular to it. Yes. So this is about the important concept and derivation of the Biot-Savart law and the SI unit of the Biot-Savart law. Okay, students. Okay, thank you.